All right, welcome everybody. So, by way of introduction, we're working on Runway. Runway is an internal developer platform that was originally developed for AI Gateway. AI Gateway could not be incorporated into the monolith because these models are just too big and that wouldn't scale. And so, in order to run these quote unquote satellite services in a kind of uniform environment, the Runway platform was created and is fairly successful, I'd say. So we have a bunch of services that are running on it today. All of the services that we're running today, they're running on Cloud Run because they're basically only for GitLab.com. So using Cloud Connector, self-managed customers can talk basically to GitLab.com and kind of get the functionality into, or for AI Gateway at least, get the functionality for their self-managed instance. But this is not an option for a handful of customers or some important customers at the very least. And so the business need is that we need to expand the platform in a way to allow self-managed customers and also GitLab dedicated to also run these services for these specific instances. And Cloud Run is not a viable option for customers that may be air-gapped or have other regulatory requirements. And so we settled on Kubernetes as kind of being the common denominator that we can kind of assume that people can spin up in their data centers where they're running their self-managed installations. Now, somewhat recently, we stumbled over the GitLab operator. And then Jason gave me a little bit of background that I've relayed to the team about the history and kind of the immediate plans for it. And Brennan and people on the team and Runway team looked at the code and basically came to the conclusion that, hey, this is pretty much what we've planned to build for Runway. And I think that there's a high chance that we would kind of reinvent a wheel that you already have built. And for kind of the long-term vision would be that users have a very easy kind of UI-driven approach to kind of deploying these auxiliary satellite services into a Kubernetes cluster. And I think that any such kind of long-term solution needs to be built into something central like the GitLab operator. And so the plan for us would be, how do we proceed so that in the long term we can incorporate with the GitLab operator? Like, we don't need to build into the GitLab operator from day one, but we don't want to be in a position where 2 years or 3 years down the line, we figure out, well, if only we had, I don't know, reused the custom resource definitions that you have, it would be so much easier to integrate. So kind of identifying some of these things that we can do now that are not really blocking us so that we have an easier time down the line, but then also kind of having a rough idea how the interaction between our teams and how the collaboration between our teams might work.
Okay, great. May I ask a quick question though?
Of
By
course.
GitLab Operator, you mean which one? Because we have two. The
Yeah.
two.
We're going to
Okay.
just assume we're talking
Okay.
about two.
Good. Good. Because
Well, yeah.
one is basically just a wraparound chart.
Yes.
Right.
Don't
Yeah.
look at it. Don't look at it.
No,
I'm
no.
just
Feel
looking
free to
at
look at it and
V2.
learn the lessons of why we did it to give us
Okay.
a progressive path forward to be able to deliver services.
That's actually
Okay.
one of the questions that I do have for you and your team. I can kind of get the idea, like I think I know the answer. I don't want to presume the answer, but because we went down the path for Runway and we're thinking about like how we're going to do deployment for self-service customers and things like that. We're like, one of our first steps was like, oh, well, let's just generate a Helm chart and then they can either consume the Helm chart directly, or we'll have some sort of controller mechanism, aka like Flux or built-in logic of our own that deploys the Helm chart.
Mhm.
But we noticed that you guys circumvented and was like, no more Helm charts, please. So why is that the answer? Um, and yeah, I'll stop there. Yeah.
Okay. So first off, how many of you are familiar with actually designing the application lifecycle, not the software development lifecycle? Anybody? Okay. Here's the thing. Has anybody heard from an operator standpoint, from a like an SRE's standpoint, the concept of days? Right? When you're designing a system for somebody to consume and use over the life cycle of that application, you have to care about day zero, all the pre-planning and requisite requirements. Day one, how do I install it? Why do I do it that way? What are my reasonings? How big does it need to be to meet my needs right now? Day two, we keep going into how do I keep it running? How do I do upgrades? When do I scale? You get into day three and further, and now you're well past what Helm was ever designed to do. So Helm itself is not it was not conceived to be anything more than a package manager. Okay. Now keep in mind, even as a package manager, if you look at it as a package manager and akin to a Linux package, not a Ruby package, not Node.js, not Python, but a package for a system, those systems have the ability to operate scripts that can actually interact with things on the system and double check, and is it available, and can I run some thing inside the thing I just deployed and get it to fire. Helm does not. Technically, it has the functionality for what it refers to hooks, and those hooks are effectively do this thing and then do this thing and then do this thing and assume that everything went well, and if not, well, try to tell the user something went wrong. Helm does not suffice the true and complete application lifecycle. It only gets you halfway. So it has sufficed us well enough, and it continues to serve our customers for the most part, but we provide them things like the toolbox image to go in and be like, okay, if there's a problem, look at this. If there's a problem, look at this. If there's a problem, look at this. Now we're dealing with manual intervention. We give them very well-defined patterns, and it works. But do an upgrade, and one of your pods is just sitting there bouncing. Why? Okay, let's go find out. Turns out, oh, you didn't wait long enough for a batched background migration to complete its sidekick job. Don't. You know, the operator V2 is being designed around the full application lifecycle with codified knowledge of how to actually operate this thing. When is it ready to upgrade? Why is it ready to upgrade? What's going on in the background that I need to wait for? True state check options that we have as a part of the omnibus, we do not have as a part of our current Kubernetes deployment strategies. And Helm just doesn't fit the need. So the operator V2 is being built now that the entire operator model and behaviors have been fleshed out as an industry, and now we can guarantee that we're delivering a good experience for our customers. We're taking everything that we've learned since the inception of the Helm chart work and since the inception of the operator pattern and the joys of working in OpenShift, and went, okay, we're done through the 200 level classes. Let's go sit down and get that senior project started.
Sweet. I loved everything you just said. And yeah, you're definitely right. Helm can't be the eventual consistency model that an operator can provide, right? And those lifecycle components. So I totally get that. I've dug into your V2 controller operator, whatever you want to call it.
Mhm.
CRD manifest is quite large. Um, and given sprawl specs field sprawls is a known field thing. I mean, just look at like Strimzy Kafka operators or things like that. But is the idea for V2 the way that your logic looks is quite agnostic. in the way that it like adds in new fields or different application components. Are you building this to be like almost as an interface to allow other dependent services to like add into it? Because before your V1 model was like, okay, um, if I wanted to add a new service, I would just add a new reconciler for a different chart, right? Um, Here, it seems more like you'll have a new service field that reconciles under that application spec. Um, is Are you designing your operator to fit to n number of services to deploy GitLab? Or is it more of like we only care about the main 5 of GitLab and just the Rails app, and I don't care about anything else? Um,
Okay.
I guess I'm just trying to get an idea of like how are you
Mhm.
when you're designing your API spec and your CRD spec, like are you trying to do n number of services, or is it like I just care about the Rails app, everything else can just go to the wayside? Because I see CAS in your
So
spec in your example,
No.
here's
so I'm
what
like,
we're going to say real quick. Roadmaps are a thing. Hussein, as the primary architect behind the current V2 setup, right? Like I'm staffing the team, but this is primarily Hussein's baby. And the basic trick comes to the same principles that we use whenever we're developing something over here, right? We try not to invent the wheel twice, especially if it's the same wheel with a new tire. It just doesn't make sense. So for the most part, the structures are not explicitly designed to be exactly this big. We try to keep in mind that there's some things that might be on or off or where or when, and you've got some malleability. So they try to be somewhat agnostic in the structure so that the scale can be adaptable.
Mhm.
Any further detail, I can just hand you to Hussein on that one.
Yeah, just to give you a quick overview, to answer, like to clear out the first big question, and definitely we are going to add more components to it. So at this stage that you are looking at it, we started with Rails application because this is the core functionality of GitLab. So generally speaking, I mean, the general architecture of the operator V2 right now is that let's assume that we are providing a Kubernetes API for GitLab Ensemble, everything that GitLab offers, starting from Rails application to auxiliary services like container registry, Cas and Shell, to satellite services that you are working on. Operator provides a Kubernetes API, and we decided to decompose that API as opposed to chart that has an all-in-one imagine chart, and Omnibus also provide an API for users to install and configure through a GitLab RB is an API, if we assume that. Kubernetes operator is the same, almost the same thing. And we had started to decompose that and start connecting these pieces together to build a GitLab instance. So the operator project at this stage, at least, is not aiming to provide a fully functional product for deploying GitLab, but provide a full set of components to build an orchestrator that builds GitLab. So it can be integrated into Git, it can replace pieces in Helm chart, or it can offer a new set of Helm charts, but it has building blocks that can connect to each other and work. Right now, actually, for our own demos and our own release project in Operator V2, we are using customized, not a Helm chart. So we are connecting the components like that, configure them like that. And the answer to other question is yes, we are looking to add more components, and we are actually encouraging other teams to participate in that. As a matter of fact, we are running a pilot with GitLab registry team, container registry team, to asking them to help us to build the API for container registry. We're not asking them to exactly to write the controller, but just the CRD is a good starting point, and we can iterate on that. As for the CRDs and why they are big, they generally reflect the complexity of the application that they are trying to represent. So the more configuration items you have, the more attributes and fields you get. And which from chart and operator v1, we learned that it is better to move forward a more specific CRD. There is also another reason, that technical reason, that your CRDs that you are looking at is big, and that's, did you look at the CRD Go files or the CRD YAML files?
So I guess I looked at your example that you provided in your doc of what a application server would look like.
Oh, okay. Okay,
Yeah.
good.
So I guess I'm looking. It might be like you're just being verbose in the
Mhm.
application server to,
Yes, we added
these
everything.
are all the configurable fields. Here's an example. Um,
Oh,
of,
yes. Oh, yeah.
you know,
Got it. Yeah, that
yeah.
definitely. That's definitely because GitLab, it's GitLab Rails. I mean, it has, just look at GitLab YAML file. It has everything. So, yes, part of the problem is that GitLab Rails is a modular monolith. And that's the best that we could do in breaking down its API into its reflection into Kubernetes API, basically.
It's just a beast. And if you don't believe me, I can walk you through why the Helm chart has the most complex set of templates that any customer will ever see or write.
Oh, I believe you. This is
Because it's absolutely nuts, to the point where multiple times I've been at KubeCon or Helm developer summits, and they're still like, and this works for you? And I'm like, yeah, it's takes a while to render, but it works. It's just a big old beast, and there's only so much you can break it down. And until the modular monolith truly becomes modular, don't see that happening very quick. It's going to require us to accept the fact that there's a huge amount of information that can be put into theirs that is either optional or required depending on what's turned on and where. And in Cloud Native in particular, there's a giant section of things that have to be configured just in relation to how it accesses all the non-stateful data. It's technically stateful because it ends up in object storage, but where is Postgres? Where is Redis? Is this one's, resilient? Giddily, don't even get me started, right?
so that's actually another component. So I before I dive into that, to the infrastructure provisioning side of things, which is also a story that Runway is looking to solve. Um, but besides that, this is you mentioned in your current like roadmap. In your roadmap, your ideal scenario is to be able to support the auxiliary services of GitLab to deploy n number of services. That would be the ideal state. In your ideal state, is say you had it, so of in your vision, how would say we have AI Gateway and Runway, say a service that's an auxiliary service, how would you imagine them onboarding into your V2 model?
Mhm.
Like, what does that story look like for
Okay.
you guys?
Okay. That's the accurate and the exact answer depends on how that new service dependent on the existing services or the other way around. That's the first question. And secondly, how it is involved in the application lifecycle. I mean, because we have certain life cycles for upgrading other services. Yes, the services are dissected and took apart, but we still have another, like a tiny custom resource that ties them together. The interface is very small. We just have set the version. So this is GitLab 17.1. I want to go to 17.3. And it starts a dance between these services to make sure that you are transitioning to the desired service. So yes, depends on all those parameters, how much it is involved in that process. But a typical the workflow for that is that you start by defining your CRD, your custom resources, and you try to reuse the existing services as well and existing API types, we call them, for the lack of better word. They are not API objects like Kubernetes resources, but they are pieces of that, like subtypes. That's the first step. The second step is starting to write a controller. Controllers are typically isolated. They do not need to interact with other controllers, but we also have a set of utilities that you can use to speed it up. And then we should start looking at those connection points, those areas that these new service has to interact with others. Most of the time they should be assumed that a rule of thumb in our design right now is that assume that you only deploy that particular service and everything else is a given endpoint. Like configuration. You have to configure it to connect to the rest.
So really,
Gotcha.
it really comes down to defining what the service is supposed to be, whatever this component is, right? Do I have version dependencies with other components, right? Like Gitly and Rails can be just slightly out of step, but generally not for long. There's times when you want to do an upgrade, and what you actually want to do is upgrade just the database, but you can only go certain upgrades at a time, right? So if we know that AI Gateway needs to be able to make outbound calls, we know that's a definition of the behavior. If it's providing a service but is not itself a client to GitLab, that's a known direction, right? What does it need to operate? What resources does it actually depend on? And what contracts does it need to have with those resources?
Okay, so it's the controller you're designing is the developer group would be extremely involved in the development of the controller or logic in the future. So it wouldn't be like very like self-service. I define a YAML of my application that I want to append as part of the GitLab operator deployment lifecycle. Um, it's much more involved, is what you're saying.
Yes.
So
In a
yes,
sense, yes.
no. So
Okay.
one thing I want to be careful with is operator versus controller. Okay. There's language differences there. A controller services some CRD or some particular service endpoint. An operator is a larger thing that does many facets or one facet very specifically well. There's also absolutely no reason that there's absolutely no reason that you can't have two operators side by side that know how to intercommunicate. Because there's controllers that know I'm this and I'm this. In order to basically ingest things off of Runway, we do need to have a means for people to declare what their workloads are. So there's a generic model involved there. But you also don't take a random piece of code and drop it in the middle of an environment and be like, give it root, have fun, bye. You just can't do that. You have to already define what you expect your thing to do, right? And if you're deploying it in Runway, you're already having to, at least in some way, declare, by the way, I expect this to consume X much resources, and it needs to talk to these things, right? The X much resources comes down to what the method of deployment looks like. Is it auto scaling? Is it CPU load? Are we preemptively defining I need to have a cluster of n+1, whatever? But you've already defined the behavior. It's part of your specification for the code. Just pass that on, and we have a framework that we can work on. Having a generic that's there that just says put this container, make 3 of them, and scale them based on CPU load is not kosher with the application lifecycle. Because if we deliver that to a customer, you haven't defined how it behaves. So they turn it on and they have no idea what's going to happen. And then the cluster falls over because it ran fully out of resources. What happened? The customer had a really bad day, and then we have to derive what occurred. So there's a mix of what is the workload actually and what is the workloads defined. But when it comes to the controller's job, you have to be able to say, this is the behavior that is according to our spec, and then making the controller aware of how to manage that actual workload is where somebody has to step in. We can only genericize that to a certain degree.
So basically, bottom line is that in most cases, you have to cut your domain in half. Part of it is the presentation, a static structure of that domain, which is reflected in your API, translated into CRD. The other half is the workload, how that CRD translates into managed resources that Kubernetes controls, deployment services, secrets. The other half is the sequencing of how am I creating these steps, when I create a deployment, when I create the service, when I wait for someone else to respond to me. And that sequencing is basically the controller, what we call controller. And that controller sits into, it's written in Go, plain Go, of course, and that sits inside the operator, like manager that we release as a full package. So we have one manager and multiple CRDs, at least one controller per CRD.
Yeah, that model makes sense to me. So today, so to flip this around, I'm building a POC of Runway, but instead of the Terraform wrapper that we have today, it's a CRD controller that takes the spec that is defined in people's repositories or service owners' repositories, translates that into a full-blown Kubernetes service, load balancer, infrastructure provisioning via crossplane, and then injecting all that stuff into a healthy service deployment similar to Cloud Run that we have right now.
Mm-hmm.
The thing about that is they also want our goalpost is, so this is where the roads start to collide, is okay, well, we do that internally for our platform, but they also want us to be able to deploy those services for self-managed customers or self-managed customers to consume Runway to deploy the auxiliary service that our developers define internally. So that's where like our collision point hits, I think, is like your service A is like you want to have the service owners more involved in the life cycle rotation of the service and that orchestration component, but we're also focused on like what does that ours is the translator between the spec that a developer defines briefly into many, many, many Kubernetes resources that get reconciled on that but we will also watch for state and things like that to ensure that the deployment is healthy, the service is active, the infrastructure is provisioned, and things like that. But at the end of the day, that's a deployment to a self-managed customer, right?
Mm-hmm.
Um, so I'm trying to see if like there's a vehicle here that either like I see two paths, either Runway, we go to GitLab Operator v2 and say, okay, we want you to be able to deploy our controller mechanism that feeds off of the logic that we have, and then we can tie in with your lifecycle management, or altogether, the Runway controller shouldn't be really self-managed, and actually we should be incorporating something that pushes into your platform.
Mm.
That those are the two doors I see in front of me.
Okay.
Um,
So there's a difference in views here. So the operator is currently effectively being designed to say, okay, this is what we expect your instance at scale to need. Install the operator into it and tell it to go at. Whereas your look you're looking at effectively being able to define, here's my workload, make somewhere for me to do it. Now deploy it into it. All right. That is a distinct difference in what the target is, because our intent with the GitLab Operator v2 is the GitLab server application, the core components of the functionality. And to have an environment that we're supposed to operate in and then go to town. So you see the distinction of letting something else go and create resources. You may not have a customer environment where it could ever create resources.
So Jason, am I understanding you're the operator, you're assuming like they have already set up their cluster?
Mm-hmm. Wherever
And
it be,
your
online,
operators,
offline, in a sub,
right,
under the water. Yes, they exist.
right. And then you're gonna like shoot the operator at it or tell the operator to like start spawning services.
Yeah, I say this from a point of example of like, yeah, I don't think AI gateway is ever going to get deployed into a submarine. But GitLab runs on several. So it's definitely one of those scenarios where, you're not transferring in 15 gigs of container images and then starting up a model. You just know, right? You have a very constrained behavior and pattern. So if you're running in the cloud or a cloud service provider where crossplane can function, then that is definitely an option that covers a fair number of clouds. It's not entirely perfect either, but they've got a pretty good interaction with all the primary ones and a few of the medium-sized ones.
It's not just
They have
crossplane
controllers.
Yeah,
Yeah.
well, we also have controllers for deploying like Kubernetes services. So it's not just crossplane will only solve if a developer wants the service to have Postgres and Redis, and the infrastructure services from a self-managed perspective would be self-service, right? So if they don't want to provision via crossplane and it's expected that they will do some sort of their own injection of their own connection strings, that will be supported. Like that's hopefully that would be support. Like so it's not like a all or nothing situation. Like it's still at the end of the day, even if I remove crossplane from the picture, it's an operator that's going. This is a runway service spec that fetches a inventory or state from GitLab and says, okay, this is what they want in Kubernetes, and goes and does the thing.
Right. So our model is effectively taking it past take the thing and put it there, where you're going to the code base and saying, this will define what the workload is supposed to be.
Right.
And ours is, we know what the workload is. This is our core functionality. We have observability and traceability and metrics over the life cycle of this thing for so long that we know generally how to operate it and how to operate it well. So there is a difference in the view on that one. So if we're only using crossplane effectively to spin up provider infrastructure for data, does it ever just add more things to a cluster? Is it ever manipulating a cluster or spawning up a new cluster? Or
No, it's not like cluster API where it's spawning a new GKE cluster, right? Or anything like that. Yeah. It's not to n number of clusters.
Hey, let me jump in. We're about 6 minutes over, so we should probably come in for a landing. I think Chance and I both have calls. This is definitely enlightening. Florian, is there anything else you wanted to cover? I feel like we got a pretty good idea about what the operator intentions are.
Yeah, I think I have a pretty good idea. We're not going to design the entire system in like collaboratively in a synchronous meeting. That's unlikely to happen. So I don't have any remaining questions that we need to address here. I'm sure I'll reach out more to Jason and Hussein as kind of this progresses, and I think Brennan is gonna do the same thing at the very least. At the very least, Brennan, possibly others. Are there any action items that we should note down for this meeting?
I think it's just keep the lines of communication open. I think that there's a clear, concrete differential between the two models and what they're trying to answer based off of what Jason said. And although very close and similar in nature, around deploying services and the orchestration around that, it's not exactly one for one, to a point where we would have to cross bridges, I think.
Yeah, I think
Yeah.
just need to
Although
reconcile our conversation.
I'm definitely starring your repository and watching it for sure.
By the
So
way, we have just a off topic. We have a demo scheduled for this Friday. Florian, it's good for you because it's EMEA friendly time
perfect.
zone. So
That
yeah,
sounds awesome.
probably if there is, I'm gonna just ask in the channel if anyone is interested in US, so we can reschedule another demo which is more US friendly. Yeah, just have a look into how it operates, how it works, how you start an instance with it. But with that, definitely, I think there are areas that these two views, two lines can connect and work together. Ideally, I think it's going to be, I anticipate that it's going to be at the orchestration level.
So it sounds to me that eventually we'll want to write additional controllers to set up Redis or Postgres for the Runway services. And it sounds like there might be overlap with what you're doing. And so if we get to this point, we'll make sure to reach out to make sure that, you know, if you have an existing, say, Redis controller, that we kind of expand that instead of rolling our own. Does that make sense?
Yeah, we're probably not gonna write a Redis or PostgreSQL controller because there are better, right, specialized operators right now.
I did make that particular example up, but I expect that we'll have some controllers that we kind of want to
Yes.
split out eventually, and if they smell like they might be useful to reuse by you or your team, we will make sure to kind of keep you in the loop on that.
Yeah, and that's the beauty of the way the operator structure is and the way controllers by nature are, is you can effectively treat them as libraries and then set who's owning something and let it go to town. So we can definitely do that over time. I think the biggest takeaway here from my standpoint is either for us to be in closer alignment, we'd have to be looking at the way GitLab operates in a different fashion. And one thing that I definitely see is Runway provides kind of an early adopter access to a lot of things. But as a service off of Runway becomes more well-defined and accepted component within the application, it could be migrated.
Yep, sounds good.
Okay, cool.
All right, awesome.
All right, thanks everybody. Appreciate everybody's time.
Thank you all so much.
Welcome.
All right.